water flows in a pipe as seen in the picture. The question is, what is the speed of the water jet in the vertical pipe? Okay, previously, we were familiar with the concept of conservation of mass in fluid flow. The rate of change of mass in the control volume plus the rate of mass flux out of the control volume through the control surface is zero. Here, the volume is symbolized as v with a horizontal line to differentiate it from the velocity symbol. In incompressible flow, the density value of the fluid at each point through which the fluid passes is constant. Thus, the value of ρ can be excluded from integral notation. Crossing out the value of ρ, the mass conservation equation changes to the following. The integral of 1 from the control volume is the volume of the control volume. By selecting a control volume that has a fixed shape, the volume value of the control volume is fixed. Or the partial derivative of v with respect to time is 0. The mass conservation equation changes to the integral from the control surface of the vector v dot vector dA equals 0. In a flow with uniform velocity, this equation can be written as the sigma of the vector v dot vector dA is equal to 0. Through this equation, we can calculate the speed of an incompressible fluid flow, and the speed is uniform. The first stage is to determine the control volume. Draw dotted lines as control volume boundaries. The next stage is to determine the physical quantities. Speed 1, v1 is equal to 5 meters per second. Speed 2, v2 is equal to 15 meters per second. Speed 3, v3 is the same as v3. Because this value is not yet known, pipe diameter 1, d1 is equal to 12 centimeters. The diameter of pipe 2, d2 is equal to 4 centimeters. The diameter of pipe 3, d3 is equal to 8 centimeters. The third stage is determining assumptions. The first assumption is steady flow. This means that the speed value at each point is fixed, does not change with changes in time. The second assumption is that the fluid flow is an incompressible flow, because water is an incompressible substance. The third assumption is that the fluid velocity is uniform. Well, now we can calculate the speed of v3. Using the mass conservation equation for incompressible flow and uniform velocity. The sigma of vector v dot vector dA is equal to 0. Well, vector A is a vector that is normal to the control surface. Because the direction of the velocity in pipe 3 is unknown, assume the direction of the velocity is out of the pipe. v1a1 cosine 180, plus v2a2 cosine 0, plus v3a3 cosine 0 equals 0. Because the directions of v1 and a1 are opposite each other. Meanwhile, v2 and a2 are in the same direction. Likewise, v3 and a3 are unidirectional. The value of cosine 180 is -1, and cosine 0 is 1. Minua v1a1, plus v2a2, plus v3a3 equals 0. Plug in all the values. Because the cross-sectional area of the pipe is a circle. Cross out the quarter value of pi, and simplify it. 64 v3 equals 480. v3 equals 7.5 meters per second. This is the speed of the fluid coming out of the pipe. Hopefully this is useful, and don't forget to watch the next video.
I feel this pain, you already know. Turn that to gains, let my money shine. turn this life into something that you can never own.